MakerSnack.
Downloading the CircuitPython Adafruit MotorKit library, configuring it for the Waveshare motor hat, and running a CircuitPython test program to get our bot moving. Part of the Mil Mascaras robot tutorial series for building a mask-distributing, phrase-talking, iOS app-controlled robot. Welcome back to our video series on building the Mil Mascaras robot. And if you've been following along with our tutorial videos and our step-by-step guide, you've configured your Pi, you've got sounds on the Pi, and we were able to run a test program to play a sound through our attached speaker, and we've assembled the robot. So now it's time to get that robot moving. So scroll down in our tutorial document to the section titled Install Additional CircuitPython Libraries to Drive DC Motors. Now at this point you could run your Pi off batteries, but since we're going to be installing software, I suggest plugging your power supply into the Pi's micro USB port for the software installation. No point in draining our batteries prematurely. Now I'll launch the Mac terminal program, log into my Pi with SSH, then I'll head back to our instructions document in the browser, and I'm going to highlight this command here, sudo pip install Adafruit CircuitPython MotorKit, and that will install additional Python libraries so we can use the CircuitPython language to get our motors moving. So copy this line, return to the terminal, paste this in at the prompt, and press return. An installation should be done in a minute or two. Then return to the browser, and we're now in this section titled Modifying CircuitPython Adafruit CircuitPython MotorKit Library to work with the Waveshare motor driver hat. Now I chose to use the Waveshare motor hat because it was the cheapest no solder option available that I could find at the time that I built this project, and I know students can be very price sensitive. Now Adafruit does make a great hat, it just supports more motors than we need in this project, so it's a bit more expensive. But that's also a great product to use. Now I have used the Waveshare motor hat before on several other projects and it works great, but unfortunately it doesn't come with CircuitPython support. But after a bit of experimentation, I figured out how to modify the library we just downloaded to work with the Waveshare hat. We just need to change 2 lines in the library code, and I'll talk you through that now. Now if you are using the Adafruit hat, you don't need to make these additional modifications, so only follow the next step if you're using the less expensive Waveshare hat. So for this next step, scroll down to the sudo nano line that ends in Adafruit_motorkit.py, highlight and copy this line, then return to the terminal, paste it into the prompt, and press return. Now this brings up the code we need to modify, and even for experienced programmers, this code can look a little gnarly. But we just need to modify 2 lines in the code that will align this software so that it works with a slightly different Waveshare hardware. And to find this line, we want to press the down arrow repeatedly to go through about 9 different screens. Now what we're going to be looking for is this line here. It's the start of a function, def motor1, and then in parentheses, self. Now when you found that, that's your heads up that you're looking at the block of code that we need to modify. We just need to change the last line. Keep pressing the down arrow until you get to the end of this block of code. It should be about 2 more screens down, and you want to find this line that says return self_motor 1, then in parentheses 8, 9, 10, close parentheses, 1, close parentheses again. Now if you scroll to the wrong page, you might see a similar line that has different numbers. You want to make sure that you're on this exact line with these exact same numbers. And what we want to do is we want to change those 3 numbers inside the second set of parentheses, 8, 9, 10. So you're going to use your arrow keys and the delete key to get rid of the 8, 9, and 10 and replace these with the numbers 0, 1, 2, separated by commas, still enclosed in parentheses like this. And when you've got that done, 1 line modified, just 1 more to go. Now if you press the down arrow to go to the next screen, you'll see the start of the next function that we need to change. Now that's the one that reads def motor2 in parentheses self, and you'll press the down arrow to go through 2 more screens. This mod is almost exactly like the one you just did, but the line we're about to change has different numbers. You want to find the line that says return self motor 2, and then in parentheses 13, 11, 12, and then there's a comma 1 at the end. And you want to make sure you have this exact line. And what we're going to do is we're going to change the 13, 11, 12 to read 5, 3, 4. And once you've done that, that's it. You've just performed surgery on a Python library. Nice work. Control X will get you out of Nano. Press yes to save changes. Press return to save it at the original spot. And we're done. So that's the end of the Waveshare specific changes. If you're using the Adafruit board, continue to follow along from here. So now we're ready to create a Python 3 program to test the motors. So scroll down to this section and we'll create this program in Nano just like we did in our sound test program in one of our previous videos. We'll call this program pybottest.py. So copy this line nano pybottest.py. We'll return to the terminal, paste it in and press return. Nano starts up. We'll return to the browser and we'll get our code for pybottest from our GitHub project page. So I'm going to open this link in a new tab. This is our GitHub project page. We've been to this before. Find the link for the program pybottest.py and click that, and here's the code that we want. Now, you don't have to know how this code works to run it, but why don't I walk you through it briefly in case some of you want to see how I coded this up and consider writing your own code for future projects. Now, this is just going to be our test code. It's not our final robot controlling code. We just want to get the wheels moving, so we're sure we've got everything wired up okay, and we've installed and modified our library. So first we import the Adafruit motor kit, and one thing to point out if you're using the Adafruit hat, I'm using the Waveshare hat. So in line 10, you have no changes to make if you're using the Waveshare hat. I want to remind you, if you are using the Adafruit hat though, to comment out line 10, and you'll do that when you're in Nano by adding a number sign as the first character in line 10. And then you're going to remove the number sign from line 8. So the lines are slightly different. If you use the Waveshare hat, you want to keep line 10 the way it is, no changes. If you're using the Adafruit hat, you want to comment out line 10, just add a number sign to the front, and you want to uncomment line 8 by removing the number sign. So I'm using the Waveshare hat, so you're not going to see me make that change in Nano, and regardless of the hat that you use, there are no changes for the remainder of this code. Now we're going to import the time library so we can count off fractional seconds, and now here's our simple code to control our motors. By setting the throttle on motor 1 and motor 2 to 1.0, the right motor, motor 1, and the left motor, motor 2, move forward at full throttle. So full throttle is 1.0, setting the throttle to 0.0 stops things. On my bot, 1.0 was fast enough to pop a wheelie. Now the bot's going to keep moving forward for 1 second. So that's what this time sleep line does. It waits 1 second after we started the motors up and running. And let me scroll this up a little bit so you can see more of the code. So here we are in line 25. Up here, we started the motors at full throttle, and we're going to wait 1 second while they run at full throttle. Then after we've slept for 1 second while the motors are running, we set the throttle back to 0.0 for both of the motors, and that stops the bot. Now we wait another second, then we perform a left turn, and we'll do that by setting our right motor throttle to half speed at 0.5, and we'll set the left motor throttle to negative 0.5. That's going to move the left wheel backward at half speed. So we'll see this left turn happen at half speed, and this would make the bot sort of spit in place. Then time sleep 2.0 makes the turning motors run for 2 seconds, then we stop both motors, we wait 3 more seconds, and then we go backwards at 3/4 speed. Notice the values in here, negative 0.75 on both of our motors, and we'll move backwards for 2.5 seconds. That's what this time sleep 2.5 does. Then we stop by setting the throttles to 0. We wait another second, and let me scroll up a bit so you can see the end of the code. And then we go backward at full speed for the right motor, but backward at only 1/4 speed for the left motor. Now there's a chance that you might see that your robot on the left wheel doesn't even turn. It doesn't move at all. And I found that when I use a throttle value either below 0.03 or in the other direction minus 0.3, that's not enough throttle value to even move that wheel. So just be aware if you're writing code to move more slowly, 0.3 might be around as slow as you can go, but you can experiment if this threshold is important to you. Now we'll run the motors in that direction for 3 seconds with this line here, then we'll stop, and our test program is done. So CircuitPython's motor kit is pretty easy to use, isn't it? Just initialize it, then set each motor throttle to the speeds that you want from 0.0 to 1.0. You can use negative values to go backwards, use time sleep for the amount of time you want to run the motor in that direction, and then you just set the motor throttle back to 0.0 to stop. So now let's highlight this code from the end of the last line to the start of the first line, copy it, head back to the terminal, and paste it into Nano. And just a quick reminder, only if you're using the Adafruit motor hat, which I am not, add a number sign or a comment marker to the front of line 10, so you're going to have to press the up arrow key until you find that line, and remove the comment marker, the number sign marker, from the front of line 8. But now we're ready to save this code, so type Control-X, yes to save, press return, and we've got our Pybot test. So now, let's test this bad boy. Now back in the browser, we can close the code tab since we don't need that anymore, and our instructions tell us to return to the terminal, stop the Pi with sudo halt, and then when the green light on our Pi stops flashing and goes off, you can turn off your power supply. If you've got an on-off switch, unplug the Pi from the power supply, plug the mobile phone battery pack into the Pi's micro USB port, turn on the AA battery pack to power the motors, turn on the mobile phone battery if you've got an on-off switch for the battery. They're rare, but mine has one, and in about 30 seconds to a minute, you could log back into your Pi. And remember, the command to execute a Python program is Python3 space and the name of the program, so you can copy this line if you want, but wait. Now I'm going to return to the terminal, and I'm going to paste it in, but not press return yet, because I want to make sure that I've got my bot on the floor so it doesn't shoot off my desk. Now, you want to give your bot about 1 meter of room on either side so that it doesn't bump into anything, and what we'll do here is I'll also show the lines of the Pybot code to underscore what the code does as the bot's moving. And when you're ready, press return on your keyboard, and oh, look at that! So how about that, bot builder? We got our bot running the test program. Next up, we're going to set up our bot with the Mosquito program that runs the MQTT messaging standard, and that's going to make it so that the bot can listen in for commands from our iOS app, and we'll also add the final control program to the Pi. Hope you feel like you're building something awesome. Keep at it.